Very good morning, students. So let us continue the same concept, addition theorem with non-mutually exclusive events. See guys, before going to the problems, I would like to give you one note. So far we have seen two events, right? In case of non-mutually exclusive, having two events A and B. But now when three events are there, how to write the non-mutually exclusive case addition theorem, which is P of A union B union C. Look at there. P of A union B union C equals to P of A plus P of B plus P of C minus P of A intersection B minus B intersection C minus A intersection C. AB, BC and CA, right? Plus the whole P of A intersection B intersection C. Please guys remember this formula as a note, because we do not have using this kind of three events problems in our syllabus. Just we have only two events, but as a note it is given that when three events are given, what is the formula of addition theorem under non-mutually exclusive events. Look at that formula once again. Clear? Right. Now let us continue the problems. In a town, 15% of the population read newspaper A and 13% of the population read newspaper B and 8% of the population read newspaper A and B, both the papers. Find the probability that a person is randomly selected, and then what is the probability that he reads either A or B, right? Here what exactly is given? Let us consider three events with its probability directly given. Probability of A 15%, nothing but 0.15. Then probability of B is nothing but 13%, 0.13. And probability of A and B, A intersection B, is given 8%, 8 by 100, 0.08. Substitute in the formula P of A union B, read either A or B paper. Here two different papers, so different papers means definitely, see here, A and B, A or B, it is asked, isn't it? Directly you substitute in the formula because all the three terms are given. P of A is given, P of B is given, as well as P of A and B is given. Then or B calculation directly, which is non-mutually exclusive case, P of A plus P of B minus P of A intersection B, together reading. So substitute those values, 0.15 plus 0.13 minus 0.08. You'll be getting the answer 0.2. Clear? Nothing but 0.20 will be getting. 0.28 minus 0.08, nothing but 0.20, nothing but 0.2. 20%, we can say it in terms of percentages. So this is the problem. Directly A, P of A and P of B and P of A and B, all the three are given. You have to substitute A or B. Now one and only formula, all the three terms where we can use is P of A union B equals to P of A plus P of B minus P of A intersection B. Clear? Yes. So we shall see few more problems now. Look at this question guys. A box contains 200 bolts and 300 nuts. A box contains 200 bolts and 300 nuts. 20% of the bolts and half of the nuts are rusted. Clear? 20% of the bolts and half of the nuts were rusted, it seems. If one item is randomly selected, what is the probability that it is a rusted item or it is a bolt? Do you understand that? So there in a box there are totally 500 items, in that 200 bolts and 300 nuts. 20% of the bolts, I mean out of 200 bolts, in that 20% of the bolts and out of 300 nuts, half of the nuts were rusted, it seems. Then if one item is selected at random, what is the probability that that item what you have selected should be a rusted item or a bolt? Now we have to see that whether this problem is exclusive or non-exclusive case. See, as I have given the heading, it is non-exclusive case. That doesn't mean that every problem becomes non-exclusive, because based on the problem you have to decide whether the problem is exclusive or non-exclusive. Clear? Right. Now just have a look once again. A box contains 200 bolts and 300 nuts. Write down. Total number of items 500. In this 500, 200 are bolts and 300 are nuts. Clear? Next, 20% of the bolts and half of the nuts are rusted. 20% of the bolts, that is 20 by 100 into nuts. Bolts how many are there? 200. So here 40, and half of the nuts, therefore half into 300, 150. Therefore total number of rusted items are 190. Are you clear, guys? Number of rusted items. So number of rusted items are 190. Next, what is to be calculated? One item is randomly selected. What is the probability that it is a rusted item or a bolt? See, out of 500, which will be the exhaustive cases, total number of items 500. Out of 500, how many are rusted items? 190 are rusted. Therefore non-rusted items were 310. Clear? Now the question what it is asked, what is the probability that it is a rusted item? So let us consider the event. Let R be an event of getting rusted item. Therefore probability of R becomes 190 by 500. Do you understand, guys? Getting a rusted item is 190 by 500. Next, getting a bolt. Let B be an event of getting a bolt. So getting a bolt, probability of bolt becomes, how many bolts were there? 200 were there. 200 by 500, getting bolts. Then R and B together, rusted item and a bolt. I mean, in bolts, rusted items how many are there? In bolts, rusted items were 40. Look at this. In bolts, rusted items were 40. Therefore probability of R and B, 40 divided by 500. Rusted bolts were 40. Clear? Rusted and a bolt together, rusted bolt, 40 were there. Now apply the formula according to the definition of non-mutually exclusive case. P of rusted item or a bolt equals to, substitute P of R plus P of B minus P of rusted and bolt. Therefore 190 by 500 plus 200 by 500 minus 40 by 500. So what answer you will be getting here? 190 plus 200, 390. 390 minus 40, 350. Therefore answer is 350 by 500. Do you understand, guys? So look at the problem once again. A box contains 200 bolts and 300 nuts. 20% of the bolts and half of the nuts are rusted. If one item is selected, what is the probability that it is a rusted item or a bolt? So let us consider first total number of items, exhaustive number of items, 500, 200 bolts and 300 nuts. So two statements are given, conditions. 20% of the bolts and half of the nuts are rusted ones, it seems. Therefore 20% of the bolts, that means out of 200, 20% are 40, and half of the nuts, out of 300, half of the nuts are 150. So 150 plus 40, together total number of rusted items 190. Next, if one item is selected at random, what is the probability that it is a rusted or a bolt? Or means definitely an addition theorem, right? Whether they are exclusive or non-exclusive, we have to see there. So probability of getting rusted items 190 are there, total number of rusted items, irrespective of bolts or nuts, whatever it is. They didn't ask, only they asked rusted item. So probability of getting a rusted items are 190 by 500. Next, getting a bolt, only bolts they are asking, irrespective of whether they are good ones, rusted ones or non-rusted ones, together whole bolts. So let B be an event of getting a bolt, that is probability of B equals to 200 by 500. Now rusted item and bolts, that means in bolts rusted items, so there is a combination which are non-exclusive. Therefore rusted bolts, how many are there? Rusted bolts 40 are there, so 40 by 500, rusted and bolt, therefore rusted bolts. So as per the definition of non-mutually exclusive, here rusted items and the bolts are non-mutually exclusive events. Therefore P of R union B equals to rusted item or a bolt equals to P of rusted ones plus P of bolt minus P of rusted bolt. Substitute all the probabilities, you will be getting the answer 350 by 500. I hope I am clear, guys. This problem, very important problem, many times it is asked in the examination, right? So very important question, guys. Thoroughly you practice this question, right? Main thing is that converting those rusted items, 20% and then half of the nuts are rusted ones, converting them. And exhaustive will never be changing it, remember guys, exhaustive case will always be fixed. Only the favorable cases you keep on changing it. Am I clear? So this is the problem, very important problem. Final answer will be 350 by 500, nothing but 35 by 50. 35 by 50 is nothing but 0.7. You can write it in decimals or in fraction also. Am I clear? Yes. So let us see few more problems now. Look at here, totally 3 examples. If P of A equals to 1 by 10 and P of B equals to 1 by 5 and P of A intersection B equals to 1 by 20. So directly all the 3 probabilities are given with respect to A, B, A and B. Now just find out P of A union B. So P of A union B, what is the formula? First write the formula. P of A union B equals to P of A plus P of B minus P of A intersection B. Substitute here 1 by 10 plus 1 by 5 minus 1 by 20. Then after doing the LCM 10, 5, 20, you will be getting the LCM 20, right? So here 2 plus 4, 6, 1, 6 minus 1, 5. So 5 by 20 will be the answer. LCM will become 20. So 10 2 times. So 2 plus 5 4 times. 4 minus 21 times 1. So 2 plus 4, 6, 6 minus 1, 5. 5 by 20 is the answer. And look at the next question. If P of A equals to 1 by 8 and P of B is 1 by 6 and P of A union B is given 1 by 4. Find intersection. Formula remains same. P of A union B equals to P of A plus P of B minus P of A intersection B. Here this has to be calculated, but here this has to be calculated. That's it. That is only the change. Interchange that. P of A intersection B equals to 1 by 8 plus 1 by 6 minus 1 by 4. So 8, 6, 4. How much it will become LCM? 8, 6, 4. 24 it will become. So 24 means 8 4s are 8 ones are 8, 8 threes are 24. Therefore 3 plus 6 4 times. 4 minus 4 6 times. 6. So answer is 1 by 24. Clear guys? So LCM carefully you do it. Next question. P of A union is given and P of A intersection B. So again write down the same formula. See, listen guys, every time I am writing the formula because it will become a practice for you. So this has to be calculated now. Remaining all the terms are given. Now substitute those. This one you take it this side. P of B equals to P of A value 1 by 6. If you take this to this side, minus it will become 1 by 6 minus how much then? P of A value is 1 by 6. P of A union B is 1 by 3, not 1 by 6. 1 second. If you take P of A value is 1 by 6 minus P of A union B is 1 by 3 minus P of A intersection B is 1 by 12. So LCM 1 by 6 minus 1 by 3 minus 1 by 12. What would be the value here? Six comma 3 comma 12. LCM how much it will become? 6 3 12 means 3 ones, 3 twos, 3 fours. Again 3 fours are 12, it will become LCM. So 6 2 times minus 3 how many times? 4 times. 1 second guys, 1 second. Why we are doing all these? Simply we can do it now directly. Substitute P of A union B 1 by 3. This we want no. These two things you take this side. P of A minus 1 by 6. This minus if you come this side 1 by 12. That equals to P of B. Then 1 by 3 minus 1 by 6 plus 1 by 12. LCM how much it will become? LCM will become 12 and then 3 4 times minus 6 2 times plus 12 1 time 4 minus 2 2 plus 1 3 by 12 nothing but 1 by 4 is the answer. So this is 1 by 4. Do you understand guys? So all the three basic problems. Directly all the three values are given. Just in the formula it has to be substituted. That's it. P of A union B equals to P of A plus P of B minus P of A intersection B. That's it. Clear? So let us see a few more problems in this concept. Now guys, both exclusive and non-exclusive problems are completed in the sense we have calculated all the examples. Still exercises were there. We can do it later in the upcoming videos. We can do all the exercise questions. We can solve one by one on board. But now every problem you observe, they did not mention anywhere the problem is from exclusive or non-exclusive. Isn't it? So far many problems we have calculated from exclusive and non-exclusive. But in the examination, depending upon the question what is given, we have to decide it. We have to arrive into the conclusion that this problem belongs to so and so exclusive or non-exclusive addition theorem. Clear? OR case means obviously you will be having addition, as I said, or sum plus union, all are addition theorem only. Remember guys, right? Only the thing is here you have to decide whether the problem belongs to exclusive or non-exclusive. Exclusive case means completely separate events. P of A intersection B will become null set in case of exclusive events. But wherein in case of non-exclusive events, that common element has to be found and substituted in the formula. So both the formulas are there. P of A union B equals to P of A plus P of B when disjoint events are there. I mean mutually exclusive. Non-mutually exclusive means P of A union B equals to P of A plus P of B minus P of A intersection B. Clear? So with this, I'm going to wind up this session, this video. So let us have few more problems as well as multiplication theorem. Right. So addition theorem problems so far we have seen. Next coming up the multiplication theorem, both independent and dependent events we have to observe. In addition theorem exclusive, non-exclusive, but in multiplication theorem dependent and independent events we have to observe in multiplication theorem, along with theorem and proof, problems on multiplication theorem. There the very important concept which we are going to discuss, it is conditional probability, which is very important in case of multiplication theorem dependent events. We have to apply that formula. Remember guys, for dependent events in multiplication theorem we have to apply the conditional probability concept, which is very important for you even in mathematics as well as in statistics. Clear? So I hope I am clear with addition theorem, both the cases, mutually exclusive and non-mutually exclusive. Hope you are following all the problems, all the videos. Then let us see a few more concepts in the coming videos. With this, I am going to wind up the addition theorem concept. Let us meet in the next video. Stay home, stay safe. Take care of yourselves. Thank you. Have a nice day.